Up next, we have Sanjay Negi. Yes, Sanjay Negi with Civil XR Austin, and he's going to talk about augmented reality to visualize H&H models. So please welcome Sanjay.
Thank you. So we're going to keep this presentation a little interactive, and we didn't have Wi-Fi, but if anyone wants to access the web presentation on their phones, they can scan this QR and they'll be able to access this presentation. Along with, if you want to ask any questions related to the presentations, you will be able to post a question on the link. That means if at the end of the presentation we are short of time, then I'll be personally taking questions at the end of the presentation, replying to you every one of the questions. And one last thing, maybe some people want to be able to view the slides that well on their phones. So if for some reason you still want to, then there is a link on the chat. You can click that, open it in the Google Slides app. With that, let's begin our presentation. So our problem statement today is that we are going to discuss about visualization of H&H models, and we are not going to discuss how to do a HECRAS model. We'll mainly focus on how to export results from these models from other civil engineering models and put it into models which are more game engines in a way, and put them into other softwares in which you can export it as a Android app, iPhone app, or other platforms. So, brief overview, having to create an AR app requires a few things in the field of civil engineering. First is you have to have the assets, the real world assets, mapped into by using a LiDAR scanner, and with the latest iPhones, you have those in your pockets. And once you scan the objects, you get a 3D model, you put it into a 3D modeling software, and once it's done, if there's a link on the website which allows you to download an app, which we created using the tools that we showed in the presentation. It's not that good, it's a really heavy app right now, but some of you will get to try who have an Android phone. And we'll discuss file types like USDZ and FBX. So I split the presentation into three parts: the LiDAR scanning, 3D modeling, and publishing. With LiDAR survey, we have access to some free apps on iOS, like the 3D scanner app, which is my personal favorite. The reason being, you can export the data you collect on this app into the formats that we are traditionally used to in our daily work life, like the GIS formats, like GeoTIFF. You can export it in those formats. You can export it in other formats, like a last cloud that you download from a USDA website. Then you have 3D modeling softwares like Blender 3D, and you have Reality Composer, which is an iOS app, and you can import those results into these 3D modeling apps. And finally, once you have everything set up, you can very easily publish it as an iOS app or an Android app using a few of the softwares listed there. And the best thing is, everything that I've discussed is free to learn and free to export. So let's move to the first part of the presentation, that is mobile surveying. And here you will see there are these two pictures side by side. The first one, it's Bull Creek, a bridge in Austin, and it's a drone video of the bridge. And on the other side, it's a LiDAR scan, which I did using the 3D scanner app on iOS. You can see that there is a ditch on the right-hand side of that 3D model, and that ditch is so easily visible that it is way far superior than all the previous LiDAR data that we used to collect from other instruments. So when I was at A&M, my professor said that what engineers care the most is how accurate the thing is, how sensitive our data is. And there is a published research on the #1 publication in the world, Nature magazine, which said that iOS measurements using 3D scanner app are as accurate as 10 centimeter for when you measure like 10 meter or bigger objects. And 10 centimeter resolution or accuracy may not be good enough for some big companies, but the versatility of being able to scan it using your phone outweighs everything else that comes up with those $10,000 top one instruments. some apps that are available on the iOS platform, and this screenshot compares what are some characteristics of these apps. Personal favorite, Polycam, and 3D scanner app. Then once you have scanned your personal surroundings, and you want to move on to getting the data into a 3D model. And if you want to some reason you don't have an iPhone, you want to skip that step, you can download a 3D model from any available online store. And you will be surprised what kind of 3D models are available out there. You can download models of bridges, you can download models of roads, big trail, and you can import it into one of the 3D modeling softwares. And if you're like me and you want to do it yourself, then Blender, this software, it has a built-in add-on called Blender GIS. What it does is, traditionally we are used to the S3 suite of products, but S3 is expensive, and if you're a big, small company, you might be well adjusted with Blender GIS, where you can import the traditional shape files, you can import the traditional GIS data, and most better of all, you can view it in 3D. And this barely takes a few steps. So, in this graphic, I'm showing how you create animation like a water surface in Blender. So, all you need to do is adjust the brightness, adjust the coloring, and adjust some few texture properties in Blender. And with that, you can get a texture which looks something like this. And it's up to you with the software's capability of handling physics, which is growing each day. You can convert and you can visualize ocean waves. You can visualize small movements in a pipe water. And it's basically up to the user how he wants to use it. And that brings us to step 3, that is publishing in augmented reality. And those of us who are from a more technical background, they might know that different platforms like Android, iOS, Microsoft ecosystems, they're very well separated by, so a lot of programmers have specializations in very few things. But for us, we don't have to worry about it, because there are some tools in which you design it once and you can export it into whichever file format your client is asking for. For example, Unity. Unity is a software which is a real-time engine. It lets you add the physics into the model. It lets you add everything into the model which you created in your MicroStation or in your AutoCAD software or GIS. And you can export it into any of the formats that we know. And if you're a big company which can afford to buy a Unity license, so Unity is free for artists and single users, but if you're a big company, you can buy a Unity Reflect Review software, which is designed for civil engineering in mind. And it lets you import all the software formats that are available from Bentley or Autodesk, and it lets you export those format files into iOS, Android, AR, VR, and other things that other people like. So before we go much into more technical aspects of this presentation, let's go back into some old trends. So we are seeing that the VR and AR market is rising, and there are over 100 million users in the US alone which are using augmented reality on a daily basis, like for example Snapchat lenses, for example Meta platform Instagram lenses, or just visualizing objects in a museum. And with 100 million of the users, you have a market that is big enough to not just, there's a market which wants Snapchat lenses and dance moves, but other market, it wants more information, and it wants to be able to visualize the real world objects like a bridge or a flood into. And another trend is that our industry also is growing at a 10% rate. But we have so far, in my opinion, have experienced 3 pivotal movements in the industry. The first one was we had Microsoft Office, and we were able to print reports from software. The second one, when we got Autodesk and GIS, and we were able to draw our 2D drawings. Then we moved on to 3D, and we are doing 3D so that we can ease up our process of doing 2D drawings. And now we are exporting these 3D models to our contractor, who is giving to subcontractor, and the subcontractor is giving to a fabricator, and the fabricator is giving back to us to verify that the design was accurate. But this is we have to streamline this whole process, and that's where augmented reality and virtual reality comes in. So what could be our target audience? We can take these augmented reality models into townhouses, or we can take it into schools. And we can educate children what an impact of a flood means when inside their phones. And our timeline of how much time we have. So for example, in 2025, Texas Water Development Board is going to present the first state flood plan. And from then, for that plan, they have built a lot of models in HECRAS and other infographics on GIS. But from 2025 to 2030, we have to be more ambitious with goals which involve flood visualization for public safety, having a digital twin of a real world. We can give more deliverables to our clients. We can give them 3D models, we can give them, but we are already doing that. But on top of all this, we can create a story revolving around our models. If we add a game character into it, then we create a story by hiring an artist. We can easily make these models that we create just for engineers more accessible to the public. Okay, back to the technical part. So how easy it is to create an Android app. You only need to export your models into this file format that's called OBJ. You watch that YouTube video that's on the link, and you are able to export the whole thing into an Android app. But Android, as we know, is not the most friendly for LiDARs and other technologies. So the big elephant in the room is iOS and how we tackle the Apple ecosystem, because traditionally engineers have been confined into Windows softwares. So we have to think about the iOS, because this $3 trillion company, which was created by these two guys, is now generating $100 billion in revenue, and they have products in line like AR glasses. And AR glasses are going to transform our industry with people who will be wearing those glasses. They would like to see a bridge, and they would want to know which year this bridge was built. They would want to know what's the structural life of this bridge. And those are the kind of data that our industry has to generate in the next 5 years as these AR lenses become more accessible. And what does this Apple ecosystem brings us? It brings us LiDARs on iPhones. It has M1 Ultra chip, which is faster than any other industry standard. AR glasses, developers. And you can watch this video in your YouTubes later, in which you can see how I modeled a stream using a LiDAR scanner and exported, and you can see what kind of things you can do with an iPhone. So Apple being Apple always puts the ecosystem inside a walled garden. So to put the AR into walled garden, they have created a file format called USDZ. But we don't have to fear that. It's called Universal Scene Description, and we only need to export our files into this format, which we used traditionally, and we put this into this app on iOS called Reality Composer. And once you have that, you just save this as a project file in Xcode. And all you need to do is copy that code, paste it into Xcode, and you have an iOS app ready with your 3D model of whatever thing you're building. And this is the source for that code. You can read that article. And finally, if anyone wants to view the updates in that project, anyone wants to see what we'll be doing in the future with AR, they can subscribe to our newsletter, and they can watch more content on our website. So I'll end this with some inspirational quotes that while we take audience question. So I did put some questions on the app, and let's see if anyone was able to take any. So I don't have any questions on that, but if anyone wants to ask a question, then please.
Can you show us the YouTube video that you mentioned?
Yeah. Oh, we don't have Wi-Fi.
Is there Wi-Fi on the?
Only guess should work. Free Wi-Fi.
It looks like I think it worked. Yeah, it's good. Okay, but I think it needs to go to this one.
Oh, that's the audio.
And So that was so what that video showed us is that we can use our iPhones and scan our surroundings, and after scanning them, we can measure like what the different units are. We can measure like different length of something, and like we showed in the slide of accuracy of LiDARs that Nature published, that with a 10-meter object you can get a 10-centimeter accuracy. So it's pretty accurate and scientifically proven. So we should like try to do it. Again, while I was doing it, I felt that it's really hard to scan a large amount of area, so I cannot put my scanner on a drone and scan the entire city of Austin. But at the same time, if you're working on a small project that requires you to model dam more accurately, then you can take your on a survey you can take your phone and scan the whole dam and do the accuracy.
Is the accuracy similar when you are drawing a small area in an urbanized location, like with a lot of buildings and stuff?
Yeah, good question. So accuracy only decreases when you have reflective surfaces like glass or water. Other than that, as long as the surface is smooth, and I think it's pretty accurate. But with water, it's
whenever you're scanning with your phone, how are you tying that into like other LiDAR elevations that you may have used in your modeling? Like, do you have a datum or a tie-in location from real-world survey, or?
Yeah, that's a good question. So there is a website from the USGS in which you can go, or NOAA, you can go into that website and find out the points which were surveyed by the US government, and you can find the elevation of that point. And it's very dense data, so every like 100, 200 feet, maybe a mile, half a mile, you can find those points. And once you have the elevation of that point from, or you have elevation of the other point, you can adjust those in either Blender, you can adjust the elevation of your data, or you can go to the other sources. But these softwares, they also have this GPS capability. So your phone also has GPS, right? So it goes with lat long and also elevation. So it will be pretty accurate. But if you want to like go very particular about that one point, then I think you can still do it by also using ArcGIS, because it exports in LAS format and GeoTIFF. So yeah, like I think we should more think about creating apps, because previously we've been so confined into creating reports for our clients. But since with Xcode or Apple Suite or with Android Studio, the process of creating an app has become much easier. We don't have to code, especially for our purposes, like when we are creating an app, let's say for Facebook, in which you require an intense amount of cloud storage. You need developers for that, to create a cloud storage for your app in which you want to connect to a database that's on internet. You need developers for that. But if you only want your clients to be able to showcase your model in an augmented space or a virtual space, then you don't need iOS developers for that. You only need to export that file into a different format. Yes, please.
Is there a way to show modeling results?
Yes, so I did create an app in which I had the HECRAS model. I exported, so the HECRAS model, 2D model, I downloaded from the examples project provided by US Army Corps of Engineers, and from that 2D model, I exported that 2D flood area into a GeoTIFF format. And once you have it in GeoTIFF format, you can go to Blender 3D, and in Blender, using the add-on called Blender GIS, you can import that file into Blender, the GeoTIFF file that's generated by HECRAS. And one thing that hasn't been solved by US Army Corps yet is that when you export the file, you only get one simulation area, like you get the maximum flood depth. You don't get like an animation of the whole thing, which you can see in the software. In HECRAS 2D, you can see the whole animation, but when you export it, you can export for one instance only. There are some tricks in which you can use a code to export multiple profiles. that would be great, because then you can be able to generate an animation on Blender. But right now, you can export that one particular instance of flooding that you want to visualize using using Blender GIS, and you can put that file into Unity editor. And once you do that, you can export or build, actually the term is right, once you get into Unity and you want to create an app, the right term is build. You build an app, you create the build, and then it builds an app for you. There is an Android app available on the website, which I shared in the first page. It's a little heavy, 500 MB. It does show a little bit of how I exported that 2D model, but again, I don't know if everyone can use it right now. Any other questions, please?
Any questions for Sanjay?
No.
Still got a little more time, if there's anything else you wanted to demo or anything? Everybody good? It's very cool.
What about the other YouTube video?
So, I mean, I don't think anyone can see my phone, but I created this app, and I have this, that's an aerial of that town, and on top of the aerial, I have exported the flood map of this city. So that helps to take and it's being projected live on top of that plane. So it helps you to like take this model that you created into town halls and public meetings and share the app with people who can install it on their phones, Android or iOS. And then they can put that model into any plane that's available out there. And then if you have more technical people, then they can put animations on top of it. And LA County has an app on iOS which allows you to see flooding and some historical things that happened with the floodplain in LA. That's a pretty interesting project also to look at. It was pretty easy to do it with Blender and Unity to create this app. But again, it's really not working that well.
Thank you, Sanjay.